Hello everyone,
Oh, yes.
I am Prashant Kapil and I am pursuing PhD in the Department of Computer Science and Engineering from Indian Institute of Technology, Patna. And the topic of my presentation is a transformer-based multitask learning approach, leveraging translated and transliterated data to hate speech detection in Hindi. So the contents of this presentation is as follows. So first I will be explaining what is hate speech, then the problem definition and the contribution that we have made, the data sets that has been utilized to perform the experiments, the methods developed, followed by the results and analysis, and the conclusion and future work. So what is hate speech? So hate speech can be defined as a broad umbrella term that describe it as any communication that demeans any person or any group based on race, color, gender, ethnicity, sexual orientation, nationality, or any other factor. So you can also see one example. So the tokens containing the harmful meaning has been asterisked. So you can see that the first sentence is related to hateful, whereas the second sentence is also related to hateful, but said in an implicit manner. So these are the definition of hate speech that have been used by the researchers to crawl the data set. So the first one is the any post that contains hate, offensive, or profanity content. Some have defined it as a post containing covertly and overtly aggressive messages, whereas in the third, the tweet will be classified as hate speech if it is using any kind of sexist or racist slur to target any minority, or sentence uh, used to support a problematic hashtag such as religious cum, which can be termed as hateful. So some have also defined it as bias motivated hostile speech aimed at a person or a group of people with intentions to injure, dehumanize, harass, degrade, or victimize the targeted group. So the last one is, it is defined as abusive speech containing a high frequency of stereotypical words. So from the table, it can be inferred that almost all the researchers have have defined the terminology, and all the definitions are slightly overlapping in nature. So so these are the some of the countries' law on hate speech. So in the USA, hate speech is legally protected free speech under the First Amendment. However, speech that includes obscenity or any other speech which can be termed as illegal conduct, those are given no protection. Similarly, in Brazil, racism is considered as an offense. In Germany, hatred is a punishable offense leading up to 5 years of imprisonment. In India, Article 19 allows the citizens. Uh, Article 19 allows to protect the freedom of speech and expression. However, Article 19 subpart 2 states that to protect integrity and security of the state, some of the tweets which are directed to defame or harass the minority comment, some restrictions can be imposed. Similarly, in Japan, hate speech does not apply to group of peoples, but covers threat and slander to protect. In New Zealand also, the Human Rights Act 93 asserts that threatening or abusive content in any form, which are directed to a group of people based on race, color, or ethnicity, is unlawful. So the problem definition that we are trying to solve is given a sentence of the form W1 to WN, The task is to classify the given post into hateful or non-hateful class. So the given example can be classified into hate because there are two abusive tokens present in the post. So the contribution is our contribution is twofold. So in the first, we are utilizing the 8 benchmark Hindi datasets that are related to hate, abusive aggression, and hostility. So for the experimental purpose, we have utilized the multilingual BERT, which is multilingual bidirectional representation from transformer, and multilingual representations for Indian languages, in short MuRIL, in 4 settings. So the 4 settings are as follows. So the first setting is single task learning, where individual data sets will be used to train the M-BERT and MuRIL. The second one is transferring the encoder knowledge to the by LSTM. The third one is multitask learning. And the fourth one is pre-training the encoder, the BERT and M-BERT and MuRIL with translated and transliterated data obtained from English, followed by the fine-tuning approach similar to the multitask learning framework. So before moving forward, I would like to explain a little bit about M-BERT. So M-BERT is basically multilingual bidirectional encoder representation from transformer, which consists of encoder and decoder. So basically BERT consists of stacking of encoders, and it is trained by pre-training from unlabeled text by jointly conditioning on both the right and left context for all the layers. So basically there are 2 steps in the training framework. The first one is pre-training. So in the pre-training, the model is trained from the Wikipedia articles from 104 languages. And in the second step, the trained model is fine-tuned to solve a given task. In our case, we are solving the classification task. So the training mainly follows 2 training objectives. The first one is masked language modeling, in which certain tokens, approximate 15% of tokens are masked, and the model is trained to predict the masked token. The second one is next sentence prediction, in which the pair of sentence is passed, and the model is trained to predict whether a sentence B follows sentence A or not. So the multilingual version of the BERT is capable of working with 104 languages, and the training data mainly consists of Wikipedia articles. So the second model that we are using to train is MuRIL. So in the MuRIL also, there are 2 steps in the training part. The first one is pre-training and the second is fine-tuning. However, it also follows 2 training objectives. The first one is masked language modeling, in which monolingual text is used to train the model. In the second one, it also uses translation language modeling, which consists of translated and transliterated pairs. The MuRIL is capable of working with 16 Indian languages, and the training data mainly consists of Wikipedia articles and common crawl from 16 Indian languages. So M-BERT and MuRIL are 2 state-of-the-art transformer encoder that we are using in our experiment in various combinations. So as I said that we are using the single task learning and multitask learning objective to solve the task. So the single task learning can be defined in which the model is trained on one classification dataset at a time by minimizing the overall loss by using the loss functions such as categorical cross entropy. Whereas in the multitask learning, the model is trained on multiple classification datasets simultaneously, and the aim is to solve more than one problem simultaneously at the same time. So these are the 8 Hindi datasets along with their classes and instances that we have used for the experiment part. So it can be seen that there are a number of different classes, although all are related to hate in some manner. So like in dataset 1, the labels are hateful and offensive. Second one is neutral. So all the dataset 1, 2, and 3 is tagged into hateful and offensive and neutral. The first part is training and the second part is test part. In the data set 4 and 5, the classes are overtly aggressive, where the aggression is made explicitly. Second one is covertly aggressive, CAG, where the aggression is hidden by using the harmful term in an implicit manner. Dataset, dataset 6 is classified into hostile and non-hostile. D7 is categorized into abusive, hate, and neutral. And D8 is categorized into hateful and non-hateful. So I would like to highlight that all the data sets are a mixture of Devanagari script, which is the pure Hindi script, as well as code mixed with English. So all the data sets are combination of code mixed as well as Devanagari script. So to move further, we also pre-processed our data set and we followed certain steps. So all the emoticons were substituted with 1 out of 5 classes. So the emoticons were mainly substituted with the word like love, sad, happy, shocking, and anger by matching their Unicode characters. Similarly, all the Twitter handles were replaced by the common word user. So we translated user into a common Hindi word, and the stop words were not removed due to the information being lost. And also empirically, we found that it has little or no impact. Similarly, to bake the hashtags into individual words, we utilize the library from Python, word segment, to break the hashtag into different words. So these are the 8 models that we have developed with the help from M-BERT and MuRIL. So model 1 and model 2 are based on M-BERT and MuRIL trained in single task learning paradigm. Model 3 and model 4 consist of transferring the knowledge from M-BERT and MuRIL to the bi-LSTM. Similarly, then model 5 and model 6 consist of training multilingual BERT and MuRIL in multitask learning framework by jointly training the 8 data sets. Model 7 consists of pre-training M-BERT with translated and transliterated data obtained from English, followed by the MTL. And model 8 also consists of same approach, but the encoder part is replaced with MuRIL. So this is the basic architecture of M-BERT or MuRIL, where the stacking of 12 encoder from transformer architecture has been used to train the M-BERT and MuRIL on different data sets. So model 1 and model 2, we utilize all the 8 data sets and pass it through this model one by one to solve the single task learning framework. Similarly, this is the model architecture for model 3 and model 4, where the last 4 layers of encoder is used. The last 4 layer of encoder is first concatenated, which is later on passed to the bi-LSTM, followed by the dense layer and the softmax layer to get the probability score. So we also trained with last 6 layers also, but we found that concatenating the representation for the last 4 layer is giving improved performance over the other approaches. So this constitute the model 3 and model 4. So this is the architecture for model 5 and model 6, where M-BERT and MuRIL is utilized to solve the share their networks among the 8 data sets, and the shared feature is used to further classify the task, different tasks by passing the representation into their task specific layers. So here you can see that we have at the start, we have some sentence or pair of sentences. After that, with the help of lexical encoder, the model derived 3 different embeddings such as word, position, and segment encoding. In the third part, we derived input embedding vector for each token. The vector size is 768. In the next stage, the transformer encoder is used to calculate the contextual embedding features, and after that, the shared feature. After that, the model consists of only the shared features, and this shared feature is utilized by all the tasks to solve their to get their probability score. And to be more specific, suppose we have 8 data sets. So the training will look like this. Equal number of samples from all the data sets will be passed through these shared layers. Let's suppose we have used the batch size of 30. So 30 samples from data set 1 will be passed through these shared layers. The weights of the shared network will be updated. Then 30 samples from data set 2 will be passed through these shared layers, and so on. After passing of each data sets, the model will be having the shared representation from all the 8 data sets. And the reason behind using this MTL approach is what we observed is that although the classes were data sets were classified by different classes, but there were many tokens which were present in all the data sets. So based on this intuition, we moved forward with the multitask learning approach to have one network which consists of shared features from all the tasks. So this constitutes model 5 and model 6. So the final, the last 2 layer consist of utilizing the cross-lingual information from English. So here, what we are doing is that we are using these 11 set of English data set classified into different hateful subclasses. And so you can see that all these different data sets have been classified into hate, offensive, racism, sexism, overtly and covertly, then harassment, then abusive, as well as spam. So we translated all these English data sets into Hindi by using Google Translate, and then these 250 translated Devanagari script, Devanagari posts were further transliterated into romanized Hindi by using IndicTrans. So we trained the encoder part with these 500,000 translated and transliterated data, and the trained parameter is used to initialize the weight of the shared encoder, which in our case is M-BERT and MuRIL. And in the step 3, we followed the MTL based approach. So these are the 4 different settings that we have utilized with M-BERT and MuRIL. And so the experimental setup is we have used the Keras framework with TensorFlow as its backend. 80% of data sets is used for the training, and 20% of data set is used for the testing part. In some of the data set, the test set were separately given. So in that case, we have trained and test as a separate part. Categorical cross entropy has been used as a loss function, Adam as the optimizer to select the best weight. Batch size of 30 is used for the shared part. And we experimented with different epochs, but we found that the epoch size of 2 is giving the optimum performance. We utilize ReLU activation function at the intermediate layer and softmax at the last layer. So you can see that the model 7 and model 8, which is mainly based on pre-training the M-BERT and MuRIL with the translated and transliterated data obtained from high resource language, English. So for dataset 1, 2, 3, 4, the M-BERT is outperforming all the approaches. Similarly, for the data 5, MuRIL is outperforming all the other approaches. Data 6 and data 7, in case of M-BERT, is obtaining the highest weighted F1 score. And in dataset 8 also, 92.17 weighted F1 score is obtained on training with MuRIL. So you can see that the translated and transliterated version is indeed helping the in improving the accuracy. So like in model 1, where the single task learning is followed, so around 3.74% increment is obtained when the single task learning framework is followed with M-BERT, whereas in M7 we are using the M-BERT pre-trained with translated and transliterated version. Similarly, for the dataset 2 in M1 and M7, around 8.31% improvement is observed. And for D3 also, comparing M1 and M7, 6% improvement is seen. D4 also 4% improvement. For D5 as also, comparing M2 and M8, around 7.64% improvement can be seen in F1 score. For D6 also, significant improvement. D7 and D8 also showing the significant improvement. So it can be inferred from this table that although M7 and M8 is outperforming all the other approaches, but M-BERT, in this case, multilingual BERT, is outperforming MuRIL. Because in all the cases, comparing M1 and M2, M3 and M4, M5 and M6, the M-BERT has won more number of, has obtained highest weighted F1 score compared to MuRIL in all the data sets. So we have also compared our approach with some state of the art. So for dataset 1, our approach outperformed the state of the art approaches by around 3%. In dataset 2 also, around 2.5% increment can be seen. In dataset 3, around 6% increment. Dataset 4, 5% increment. Dataset 8, very significant improvement of around 12%. So the proposed approach where the translated and transliterated dataset has been used to pre-train the M-BERT and MuRIL, it can be seen that the improvement is in between 6 to 12% for all the datasets. And in Hindi, in the hate speech detection part, as Hindi can be termed as low resource language compared to English, where there are very few data sets available for the hate speech detection or offensive speech detection. So we have utilized almost all the available data set to experiment by using M-BERT and MuRIL. And we have observed that to solve the low resource language such as Hindi, where the available data set is mainly written in pure Devanagari script or code mixed language mixed with English. So because there are numerous instances which are code mixed in nature, and the BERT or any transformer encoder based approach is trained with pure language, not by code mix language. So there are only few code mix data sets that have been used to train the traditional language model. So in our case, we are using the high resource language to generate synthetic samples, especially for the code mix part, to help in training, and the results are very much aligned with that approach by getting improved performance of 6 to 12% for all the data set. Yeah, thank you. So if you have any question, you can ask.